Hello there, it's some more maths for some Year 13 students, A-level maths, and we're looking at the change of sign method. But now the change of sign method is a method to try to work out the answers to equations that otherwise you wouldn't be able to solve. Because some equations are physically impossible to solve, and so using algebraic means at least. And so we on those situations we tend to use what are called numerical methods, and basically it's a trial and error kind of let's guess an answer, see if it's right kind of method. It does get more complicated than that, and the pictures on the screen perhaps suggest that more complicated methods, but today's lesson really is quite straightforward. So we call it the change of sign method, and basically if you have, like I've drawn a function here, and if you have a root, and a root is basically a point where the curve crosses the x-axis. Obviously our x-axis is here, and you can see it crosses in this point here. If there is a change of sign in the function, then basically what that means is one part will be positive here, and one part will be negative. And by definition, as long as it's a continuous function, it just doesn't magically jump from one side to the other. If it's negative down here and positive up here, somewhere in between it must have crossed this x-axis. And this is what this says. It says if y equals f of x is a continuous function, and f and a and f and b have different signs, there must be a root in the interval a, b. So we basically look for two numbers between which the sign of the function changes. And here is an example of that. So there's the graph that we were looking at before, and I'm looking at a particular point. It says you can notice that it's a little above the x-axis, what I've called the 0 line. Obviously this x-axis is also called the 0 line. So at 0, x is 0, I can see it's got a value of 2. And then at x equals 1, it's got a value of minus 2. So effectively we've got a change of sign between these 2 points, and that tells us there must be a solution somewhere in between. Somewhere in that interval from 0 to 1 there must be a root. So we can look at this properly. It says by looking at f of 0 and f of 1, and this is what you do in an exam. You put 0 into the function, you put 1 in the function. When I put 0 in I get 2, when I put 1 in I get minus 2. When we write the change of sign, therefore a root belongs, this is the posh mathematical symbol to belongs to, the interval 0 to 1. There must be a root somewhere between 0 and 1. That's really all we're doing. We're looking for this change of sign. So sketch a graph then. Here's another example of y equals x cubed minus log x minus 2x. Now you can do this on your calculator. You don't have to suddenly magic up this from the top of your head. So I want you to type that into your calculator, obviously your Texas TI 84 Plus calculator. And that's what I got when I did it. Now again, it's not symmetrical. If you look at it carefully on this, you'll notice it seems to be sort of slightly asymmetrical. But you can also see it says use the trace function on your calculator to find integer bounds. Now I've got these, you might be able to do it more easily, but there is a trace function on your calculator, and I want you to use it. So the trace function is actually there. And so when you draw your graph in, obviously you've drawn your graph in. If you press that trace button, you can move the cursor left and right on your screen. And what that allows you to do is to find roughly, so you'll be able to look and you'll say, it says find integer bounds for the second positive root. Oh, actually we're looking at this one here. We're trying to find this. So I want you perhaps to find a value, presumably this one. Look at there, and you'll probably see that when you put 1 in, I'm guessing it's 1 because I haven't got a scale on this, but I'm guessing it's 1. And when you put 2 in, so when you look, you can see it basically crosses between 1 and 2. So let's use the trace. You might find it crosses at 1, I mean looking at my graph it's about 1.5 or 1.6 or something. So it's around that kind of value, and you might be doing it by doing that. By seeing that it crosses at 1.6ish, you're thinking, oh, it goes between 1 and 2. So I would say here the root lies between 1 and 2. and I don't know exactly where it is. And then it says use the chain of sign method. So basically I set up f of x to be x cubed minus log x minus 2x. And then I put my 1 value in. So I'm going to do that now on my calculator. So go into the table function, and again there is a table function here. If you've drawn your graph in, the advantage of this calculator is it does it automatically for you, and it is a big advantage actually of the drawing the graph, because then you've automatically got your table function ready done. I haven't used it, I haven't got that calculator here unfortunately, so I'm having to type it in. X cubed minus log x minus 2x. And I'm starting at 0, going up to 3, and step of 1. Yes, so I've got that. So I've got f of 1 is, according to me, equal to minus 1. F of 2, according to me, is 3.31. And I just write here, change of sign. Therefore, the root lies between 0 and 1. And it says use your change of sign method to find the error interval to this root to 1 decimal place. Actually, it wants me to do it even more accurately, doesn't it? So I've got to now focus in. Well, I suggested about 1.5, so I'm going to now have a look at what 1.5 is. Again, it's just a case of going back to your table and just changing the step function. Going up this time in 0.1s. And what have I got? I've got 1.5 equals, well, it's pretty close, minus 0.03. I've got f of 1.6, which I'm going to assume is positive. Let's go, yes it is, it's 0.4259. The advantage of your calculator here is it does all the work for you. Change of sign. If you're not sure how to use the table function, you want to Google it or email me or come and see me in lesson. Change of sign, therefore the root lies in the interval 1.5, 1.6. My initial guess here was quite close. So let's just see what the answers actually say. Yeah, that looks right. A root between 1.5 and 1.6. So another example for us, we've got this, sketch this graph of 5 over x minus 2x plus x squared. And then it wants us to show that there is a solution between minus 1 and 2. So let's first of all sketch it. So this was my sketch when I did it on the calculator, and I quite like the fact it hasn't actually got clear, obvious places where it crosses. You can use the trace function to prove this in your mind, but it does say show that, and we now know that in order to show that, this is for part B, to show it, we put minus 1 in. So again, I'm going to do a table function. So what's my function? It is 5 over x minus 2x plus x squared. So again, it's not an obvious graph that you tend to know. It says show that it's in between minus 1 and minus 2. So I'm going to start at negative 2. I'll go up to negative 1 with a step of 1. And it just tells me f of minus 1 is minus 2. The one before it, f of minus 2, is 5.5. So there is a change of sign here. And I want to see those words written. Change of sign. To show everyone you know exactly what you're looking for. Therefore, there is a root that lies between minus 2 and minus 1. Evaluate these 2 points. Okay, fair enough. Presumably there's a change of sign there as well. So I'm going to try minus 0.5 and f of 0.5. Oh, I've just seen why they are asking me to do that. But I'll just do it first of all. So what's it want me to do? It start at, I'm going to say negative 1, end at 1, going up in steps of 0.5. And you should notice, interesting, when I've done that, at 0 I've got an error. But this one is minus 8.75, so it's negative. This one is 9.25. This is positive. So surely, I hear you cry, there's a change of sign. So since there's a change of sign, part D says, why does this not imply there's another solution between? Well, if you look at the graph, it tells you, look, there doesn't seem to be a place between there and there where it's crossing this x-axis. And it's because it's not a continuous function. So I'm going to write, but not a root. Since, and the posh way of describing this might be something like, since there is an asymptote. Here's an asymptote at x equals 0. So there's no root because it doesn't cross over gently in between as a continuous function would. It's a discontinuous function, I suppose. There's an asymptote in between stopping it, and it just jumps up there. Yes, and that's what I wrote. And it's not continuous, so it's exactly what I've said. So next question, change of sign again. Draw on the same axis the graph of y equals root x and y equals 1 minus x cubed. Well, you can type that into your calculator. I'm going to quickly do it. There they are. Y equals root x is clear. This one here, the blue one, is y equals 1 minus x squared. And you can see these two cross at around, that looks like 0.5, so I'm going to say about 0.6 again. Use the trace function to find integer bounds, so presumably I can go f of 0 equals. Now notice I've changed this here. In order to solve this, I'm really solving a simultaneous equation, so I've got root x equals 1 minus x cubed. Now to my function then, I have to have them all on one side. So I'm going to say my function is root x minus the 1 minus the x cubed. So, plus an x cubed when it moves over. So f of 0, if I put 0 into it, I get 0 and 0, I get minus 1. And if I do f of 1, I get root 1 is 1, or minus 1, I think I get positive 1. And therefore I get a change of sign. And therefore my root lies between. These are the integer bounds it talks about. I give it 2 integer answers, and then it says actually now do it to 1 decimal place. Okay, it looks about 0.5ish, 0.6ish, so I'm going to type in this into my calculator. So f of x, what have I said it's equal to? I said it's equal to root x minus 1 plus x to the power of 3. Start at, well, I've said 0.5, and go up to, I'm going to suggest 1, going up in 0.1. And what have I got? Well, I've got 0.5 is minus 0.167. F of 0.6 looks a really, really small answer, actually. It says minus 9 times 10 to the minus 3. That's minus 0.009. So actually f of 0.7 is the interesting one, because that's when it becomes positive, 0.1796. So between these two there's a change of sign. And therefore to 1dp I think my root belongs to 0.6 to 0.7. Now I think it's really, really close to 0.6. That's because it's so close to this answer being 0. But don't know for sure, so I just say it's between 0.6 and 0.7. And that's what I've got there. Good. I've got this one equation left. It says show that the equation log of x equals x to the 4 has a root at 8.6 correct to 1 decimal place. Now to show that, a couple of things here. I'm going to have to write f of x. I'm going to have to get it all onto one side, so that moves over. I'm going to write log of x minus x over 4. That's the first step. And I think I need to show that it's 8.6 to 1 decimal place. Notice it says is this. So I think it's got to be between, remember error bounds at GCSE, 8.65 to 8.55. And I'm going to ask you to find those two things and see if there's a change of sign. That's what I want you to do. In the meantime, there's the answers, see if you agree with those, and in class we'll do exercise 14a. You might need to pause the video to see those answers properly, but I want you to go through the process of seeing if you can finish off that last question. Thank you very much. I'll do it for the first lesson on numerical methods.